students, in today's video we are going to discuss about very important concept, bond enthalpy. It is also denoted by delta H naught. First of all, definition of enthalpy or bond enthalpy. It is also called bond energy. What is bond enthalpy? The enthalpy change required. The enthalpy change required to break a particular covalent bond in one mole of gaseous molecule. To produce gaseous atoms or ions or free radicals. It is called bond enthalpy. The enthalpy change required to break a particular covalent bond in one mole of molecule to produce gaseous atoms, ions or free radicals. It is called bond enthalpy. You are familiar with atoms and ions. But what are free radicals? A species with an odd electron, it is called free radical. During cleavage of any bond, these spaces are formed and therefore they are to be mentioned in the definition. Now explanation. Actually, bond enthalpy is amount of energy required to break a particular bond in one mole of molecule. It may be also defined as amount of energy liberated during formation of particular covalent bond in one mole of molecule. As both these values are same, they only differ by sign. Therefore, practically, instead of energy liberated, energy supplied is considered for bond enthalpy, and therefore such definition is given. First point, as covalent bond is broken by supplying or by absorption of heat. Bond enthalpy is always positive. That is delta H naught positive. Second, there are two types of molecules: diatomic, monoatomic, diatomic and polyatomic. Three types. Monoatomic molecules exist in case of inert gases. They don't have any chemical bond. Therefore, forget about monoatomic molecules. You think of only diatomic and polyatomic molecules. In case of diatomic molecules, molecules containing two atoms, there is only one bond in diatomic molecule, and bond enthalpy in case of diatomic molecules is accurate and specific. As the molecule contains only one bond, but in case of polyatomic molecules, in case of polyatomic symmetric molecules containing same type of bonds or identical bonds, bond enthalpy of every bond is different. Hence, to avoid the difficulty in specifying bond enthalpy of such identical bonds, the concept of average bond enthalpy is considered. Average bond enthalpy, average bond enthalpy is approximate and inaccurate. These are some points regarding bond enthalpy. First of all, in case of bond enthalpy, bond is to be broken by absorption of heat, and therefore bond enthalpy is positive, always positive. In case of diatomic molecules containing only one bond between two atoms, enthalpy is accurate and specific. In case of polyatomic symmetrical molecules containing identical bonds or same types of bonds, bond enthalpy of every bond is different, and therefore it becomes difficult to specify bond enthalpy of any of these identical bonds because they have different values. And to avoid these difficulties, a concept of average bond enthalpy is taken into consideration. Average means addition of bond enthalpies of all the identical bonds divided by number of bonds broken. This formula can also be given. Average bond enthalpy delta H naught. It is total bond dissociation enthalpy divided by total number of bonds broken. This ratio gives average bond enthalpy of a particular bond in polyatomic molecule. We will see some examples. Next point. First point. Average bond enthalpy average bond enthalpy of OH bond in water molecule. Water molecule contains two OH bonds, and both these bonds can be broken. Water contains two identical OH covalent bonds, and bond enthalpy of every OH bond is different. If first OH bond in gaseous water molecule is broken, we get OH gas plus H gas, and enthalpy change of this OH bond, it is 499 kilojoule. If you break second OH bond, OH gas breaks to give O gas plus H gas. In this way, one by one, both OH bonds in water can be broken, but here bond enthalpy of every bond is different. Bond enthalpy of this second bond is 428 kilojoule. Although both the OH bonds are identical in all the respects, their bond enthalpies are different, and therefore difficulty arises before us that bond enthalpy of what bond is to be taken into consideration. To avoid this difficulty, average bond enthalpy of this is calculated. Here, total bond dissociation enthalpy is calculated calculated by adding these two, it is plus 927 kilojoule. Now from this value you can calculate average OH bond enthalpy delta H naught of OH bond, or it can delta H naught OH. It can be given as total bond dissociation enthalpy divided by total number of bonds broken. Total bond dissociation energy is 927 kilojoule divided by, here two bonds are broken, and if you calculate this ratio you will get 463.2 kilojoule. This is average bond enthalpy ABE delta H naught OH. This is one example. Second example can also be cited here. Second enthalpy, average bond enthalpy of CH bond in methane molecule. Methane molecule can be written as CH4. That means it contains four identical CH bonds, and all these four bonds, CH bonds in methane, are identical in all the respects except their bond enthalpy. Now, if these bonds are broken one by one, different amount of enthalpy change takes place. First, when first bond is broken, CH4 gas gives CH3 gas plus H gas. First bond is broken, and enthalpy change of this reaction is 427 kilojoule. If second bond from CH3 gas is broken, we get CH2 gas and H gas. Bond enthalpy of the second CH bond is 439 kilojoule. C. Third, if you break third CH bonds from CH2 species, we get CH gas plus H gas, and bond enthalpy of this third CH bond is 452 kilojoule, and when last bond from CH species is broken, we get carbon gas plus H gas, and bond enthalpy of this fourth bond is accidentally lowest 347 kilojoule. In this way, although all the CH bonds in methane are identical, but depending upon environmental conditions, electronic conditions, bond enthalpies of these bonds changes. And bond dissociation enthalpy, bond dissociation enthalpy can be obtained by adding all these four species values, we get it as 1665 kilojoule. Now average bond enthalpy, that means delta H naught Cl is given by the ratio total bond dissociation enthalpy divided by total number of bonds broken. This is the formula. Here total bond dissociation energy is 1665 kilojoule. How many bonds are broken? 4. If you calculate this ratio, we will get 416 kilojoule per mole. This is the bond enthalpy of CS bond. In previous example, bond enthalpy of OH bond we have calculated. It is 463.5 kilojoule per mole. First of all, bond enthalpy of OH bond. We have seen it. Mistakenly, I have given unit only kilojoules, but it is actually kilojoules per mole. 463.5. In this way, we can define and explain bond enthalpy as well as average bond enthalpy. Now, next point in this respect, we have to discuss about bond enthalpy can be calculated bond enthalpy is also useful to determine enthalpy of reaction. Now next point, enthalpy of reaction, delta RH naught from bond enthalpies. We have to obtain a formula for bond enthalpy or enthalpy of reaction or heat of reaction from bond enthalpy. Generally, in a chemical bond or in a chemical reaction, reactant bonds are broken by absorption of heat. Absorption of heat, and therefore enthalpies of reactants are always positive. On the other hand, product bonds are formed by liberation of heat. Liberation of heat, and therefore bond enthalpy of products is always negative. By keeping these 2 points in mind, you can write formula. Now addition of algebraic sum of bond enthalpies of reactants and bond enthalpies of products is nothing but enthalpy of reaction. Here enthalpy of reaction, it is nothing but addition of energy absorb during cleavage or breaking, cleavage of bonds, cleavage of bonds in reactants, plus energy liberated during formation of bonds in products. Now here energy liberated during cleavage of bonds or energy absorbed during cleavage of bonds is positive, and it is nothing but total enthalpies of products, total enthalpies of reactants. You can write it as summation of enthalpies or bond enthalpies of reactants plus, now this is energy liberated during formation of product bonds, that is bond enthalpy of products is negative, therefore you write negative summation of bond enthalpies of products. This is the formula. Now, if you write this formula in modified way, it becomes delta RH naught is equal to summation of delta H naught reactants plus into minus summation of bond enthalpies of products. This is a mathematical equation for enthalpy change from bond enthalpies. For example, consider a reaction H2 gas plus I2 gas to give twice HI gas, and we have to calculate standard enthalpy of this reaction. For that purpose, what is required? Bond enthalpies of HH bond and II bond per mole are required. HI bond here delta H naught, II bond must be given in kilojoules or joules per mole, and delta H naught II in kilojoules per mole. Third one, delta H naught HI. Three spaces are there and three bonds are there in the reaction. Here you have to keep one thing in mind, that in bond enthalpies of all the bonds given must be used in same units along with signs, and then enthalpy of the reaction can be given. Now, for this reaction, standard enthalpy of reaction delta RH can be given as standard summation of standard enthalpy of reactant bonds minus standard enthalpy of product bonds. Now, you can calculate in general on enthalpy. Now reactants, there are two reactants, standard enthalpy. Now here one more is there, that means 1 into standard enthalpy of HH bond plus, this is one in one bracket, plus 1 into standard enthalpy change of I bond. Bracket complete. This is about reactant bonds. Minus only one product is there, 2 into standard enthalpy change of HI bond. Here 2 HI bonds are present and therefore you have to multiply enthalpy, bond enthalpy of HI bond by 2. In this way you can calculate enthalpy of any reaction from bond enthalpies of the bonds of reactants and products. Here, not only enthalpy of reaction can be calculated from bond enthalpies of particular bonds, you can also calculate bond enthalpy of particular chemical bond from enthalpy of reaction and enthalpies of remaining reactants and products given. This is about bond enthalpy, average bond enthalpy and enthalpy of reaction bond from bond enthalpies. Next time we will discuss about numericals on these units. Thank you.